Today, I'll start my experiment by adding hydrogen peroxide to this glass. Now I will add a few drops of dish soap. Now I will add a few drops of food coloring. And now I will stir it. Now I have my warm water running, so I'm going to take some yeast. And add some warm water. Just waiting for the water to get warm. So I'm going to add it to the glass. Add a little bit more yeast. And give that a stir. Now I will add the two solutions together. And you see how it's rising and foaming. Add some more. And you can see that it's still foaming and pouring out. You can see my hands are foamy. It's bubbling here and still coming out. You can see this type of reaction. So now I'm going to explain the chemistry behind what happened in the experiment that I just performed. So basically, when hydrogen peroxide breaks down, it goes into oxygen or O2 and water, H2O. Normally, this breakdown happens very, very slowly, but the reaction can be sped up by using a catalyst. And as we learned previously in this course, is that a catalyst speeds up the process of reaction. So yeast, which is used in this experiment, is an organism that contains a chemical that's called catalase, and catalase ends in ASE, which is typically means that it's an enzyme. So catalase is an enzyme, which is a catalyst, and that enzyme helps break down the hydrogen peroxide and speeds up that process of the breakdown of hydrogen peroxide. So catalase is present among almost all living things that are exposed to oxygen, and it just happens to help break down and catalyze the process of naturally occurring hydrogen peroxide. So this means if you mix yeast with hydrogen peroxide, then the hydrogen peroxide will rapidly break down and in turn will turn into water and oxygen in the gas form. And oxygen in the gas form, which we've learned in previous experiments and also in this experiment, forms bubbles. And these bubbles want to, and usually would, escape from the liquid water, H2O, and pop up quickly. However, when we add the dish soap, we're adding additional surface tension to the solution. This additional surface tension from the dish soap allows the bubbles, or the oxygen bubbles, to get trapped, which ends up creating a lot of foam rather than just bubbles. This foam, when it expands, I guess, looks like a giant squeeze of toothpaste. So big that it can be called elephant toothpaste because it could be a toothpaste used for elephants. So that's why we saw what we saw. However, I just want to add that I was only able to obtain 3% hydrogen peroxide. I couldn't find 10%. So I want to note that if I used hydrogen peroxide of a higher concentration, we would have seen more of a reaction like what we did in the video that was used for the example.